Hello everyone, my name is Bolatfe and I'll be taking you binary expansion. When you have variables, for example, let's say x plus y raised to the power. Okay, so for this type of question, because the power is still raised to the power of 2, you can do the normal expansion, which is x plus y, right? And you have x times x plus y times x plus y. Then expanding it gives x squared plus xy plus y squared, which is equal to x squared plus 2xy plus y squared. Okay, so for this kind of question, it is very easy to expand it once because the power is raised to 2. What if you have x plus y raised to the power of 4? Here we can't keep doing expansion 4 times. So that is where binomial expansion techniques kick in. And we have 2 different techniques for it. The first is using the Pascal's triangle, and the second is using the combination method. So we'll be starting with the Pascal's triangle method. And the first thing you need to know is how to generate your Pascal's triangle. So for your Pascal's triangle, you start with the first level is 1, 1. So generating other levels for it, you start with 1 and add the numbers in the previous level. For example, this is the first level. To get the second level, you add 1 plus 1, which is 2, and close it with 1. To get the third level, you start with 1, 1 plus 2, 3, 2 plus 1, 3, and you close with 1. To get the fourth level, starts with 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and close with 1. So you keep doing that till any level you want. For this question, we have x plus y raised to the power of 4. So this is our level 1, this is the level 2, this is level 3, and this is level 4. So what we will need here is the level 4 numbers. Now, what these numbers really do? These numbers are just the coefficients of expansion. Okay, so the first number here is 1. So you write 1. Now you have 2 variables, x and y, raised to the power of 4. So what you do is you pick the first variable and start with the highest power. So you have x raised to the power of 4, since x is the first variable, plus the next number on our triangle, which is 4. The first number again, the first variable again, x. But as you proceed, you reduce the power of this with 1 and increase the power of this with 1. So here we have x raised to the power of 4. If you reduce x raised to the power of 4 by 1, you have 3y raised to the power of 1. So the next number, 6 plus 6, reduce x squared y raised to the power of 2, plus you have 4, reduce x, that's x 1, y raised to the power of 3, and lastly you have 1. Reduce x. If you reduce x, you have x raised to the power of 0. So x leaves, and you end up with y raised to the power of 4. So in just one line, you've gotten the value of expansion of x plus y raised to the power of 4 without having to go through this long process. Now let's do this same thing we did in a log process in just one line. It's in our Pascal's triangle. X plus y squared. So here our power is 2. So what we need is just our level 2, which is 1, 2, 1. So same thing you did. Start with 1, x. Now the highest power is 2 here, so you have x squared plus our second number 2. As we proceed, you reduce the power by 1, that's 1, and increase the power of this by 1, plus the last number there, which is 1. Here, if you reduce 1 by 1, you have 0, so x leaves, and you have y raised to the power of 2. So just like that, we've gotten x squared plus 2xy plus y squared, which was the same thing we got here in 1, 2, 3, 4 lines. So with the help of Pascal's triangle, no matter how high the power is, you can get it in 1 or 2 lines maximum. So let's take other examples and let's deal with numbers. But for other examples, I want us to go down more into more levels. So still the same way we generated our triangle. It starts with 1, add the numbers in the previous level. 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5. There's nothing to add again, close with 1. And remember, this is our level 5. Continue that way, open with 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, close with 1, then we have our level 6. So let's take real numbers for example. Let's say you have 1 plus 2x raised to the power of 6. Okay? You have 1 plus 2x raised to the power of 6. So using our Pascal's triangle method, now we'll also be introducing the combination method. Since I said we have two different methods to solve it, we'll use Pascal's triangle method and we'll use the combination method. Pascal's triangle, you have to generate this triangle and use it. For the combination method, you just need calculator or just your knowledge of combination generally. So using our Pascal's triangle, if you go back to your triangle, we have the coefficients. So let's write the coefficients here so that we won't have to be going back and forth. The coefficients there are 1, 6, 15, 20, 15, 6, 1. Those are the coefficients on level 6 there. So what we need to do here is just start with the first number, 1. Now, remember what we did here. We said the first number takes the highest power. So we have 1 raised to the power of 6 plus the second number, 6. 1, you reduce the power, that's 5. Then everything you have here, which is 2x, goes in this power of 1. How to know you are correct? Your power must always add up to 6. 5, 1, 1, 1 added up to 2. 5, 1 adds up to 6. So the next coefficient is 15. Then you have 1 raised to the power of 4, 2x raised to the power of 2. The next coefficient is 20. You have 1 raised to the power of 3, 2x raised to the power of 3. Do you get the pattern? You reduce 1, increase 1, still the same thing. Plus, you have 15, 1 raised to the power of 2, 2x raised to the power of 4. Plus, the next one, 6, 1 raised to the power of 1, 2x raised to the power of 5. And the last one, 1. But because 1 has gone out here, obviously you have 2x raised to the power of 6. Yeah, we know 1 raised to the power of any number is still 1. So we don't have to bother about the ones. What we need to deal with are these ones in the brackets. So let's move. Yeah, you are going to have, this is still 1. Everything here is 1. 1 times 1. Plus, this is 1. 2x raised to the power of 1 is still 2x. 2 times 6 gives us 12x. Plus, this one goes out 1. 2 raised to the power of 2 is 4. X raised to the power of 2 is x squared. 4 times 15, you have 60x squared. Plus 2 raised to the power of 3, 8. 8 times 20, 160. 160x cubed. Plus 2 raised to the power of 4, 16. 16 times 15. 16 times 15 gives us 240. That's 240 x raised to the power of 4. Plus 2 raised to the power of 5 is 32. 32 times 6 gives us 192. So you have 192 x raised to the power of 5. And 2 raised to the power of 6 is 64. 64 x raised to the power of 6. So we successfully expanded this to the power of 6.